comparing fractions again today. We learned one really important thing to remember when comparing fractions. What was that one thing we have to keep in mind when we are comparing fractions? We did this probably on Tuesday a little bit when we were talking about pizzas. We were talking about subs. Aiden? Let's fix our language in there. The wholes have to be the same size. It is not going to be a fair comparison if Aiden eats a half a pizza and I eat a half a pizza, but then we find out that Aiden's pizza was extra large and Miss Miller's pizza was extra small. That's not a fair comparison. So when we are comparing fractions, I'm writing, therefore you are writing. The wholes have to be the same. So in real life, you need to be ordering the same size thing. So if we're talking about pizzas, if me and Aiden both order the same size, then we can compare. If we're talking about cake, and we have two of the same size wholes, then we can compare. How do I show that things are even if I'm doing a bar model? How do I show my models are even if I'm doing a bar model, Aiden? Before I even start making fractions, how do I show that my models are even? How do I show my models are even? Aiden? Nope. Ava? Nope. Jackson? They are the same size. If I'm doing a bar model, my bars or my rectangles need to be the same size. If they are the same size, then I know that that whole is even. Is there a reason I'm writing and you're just hanging out? So there's a couple ways you can do this. You can either draw a bar and then draw a bar directly underneath it. Or some of you got pretty clever, and what you did is you made a really big bar and then you just went like this. So now you know both of those are completely even. Because one bar is worth one whole. You need to make sure the whole bar is the same size. Yes?
We have it with sandwiches.
Kinda. Kinda. Any questions about that? Yep.
So like if you want to know if like they're the same size or not.
Yep.
Another way can be like if you split it and the other one has smaller size and the other one has like a big size.
Yep, so we're going to get into partitioning our fractions, but right now before we can even start fractions, we have to make sure our wholes are fair. Alright, so let's now go in and compare with our bar models. So number 1, Blake ate 2/6 of the cake. Jackson ate 2/4 of the cake. Who ate more? How do you know? We are comparing fractions. We are comparing fractions.
Comparison.
We are assuming the cake is the same size. same cake. So let's go ahead and draw our 2 bars. I recommend the bigger the better. I would go pink line to pink line and trace, because you already have straight lines in your notebook. So go ahead and draw your 2 bars in your notebook. Okay, we are comparing 2 6 versus 2 4ths. Those are the 2 fractions that we're comparing. I want to know who's eating more cake. So let's make the top bar, how about Blake? So I'm going to put a B next to the top bar, B for Blake. How many pieces am I going to partition that bar into? How many pieces am I partitioning that bar into? Lindley, what do you think? Blake ate 2/6 of the cake. So how many pieces do I need to break my bar into? 6. Why?
The denominator is 6.
And the denominator tells us what? What does the denominator tell us? It does tell us to break apart into 6 pieces. That's right. But what does the denominator tell us, Arizona? How many pieces in one whole? Is 6 an even number?
Yes.
Yes. So let's start right in the middle.
Oh, I did.
Now I need 3 on one side and 3 pieces on the other side. All right, I have successfully partitioned that bar into 6. I feel like I'm spitting every time I say that. How many pieces did he eat? How many pieces did he eat, Ryan? 2. How do you know that? Not the denominator. The numerator, which is 2, tells us how many pieces we're using. So we're going to shade in 2. Here's tricky. Pause. Technically, we know I can shade in any 2 boxes I want. I could shade in these middle 2 if I really want to. That still shows 2/6. However, since we are comparing, it makes it way easier if you start on one side and go across. This is not wrong. This does show 2/6. It just makes it a lot harder when we are comparing. So we're going to color in the first 2 pieces. All right, here's Blake. Cool. Now we go to Jackson. Second bar, I'm putting a J. J for Jackson. All right, Jackson. How many pieces am I partitioning your cake into?
4.
How do you know that? The denominator tells me how many pieces are in my whole. My denominator is 4. Is 4 an even number?
Yes.
I'm going to split it right in half again. Now I need 2 pieces on one side, 2 pieces on the other side. Caleb, how many pieces did Jackson eat? How do you know that? The numerator is 2. Again, I can color in any pieces technically, but to make it easy for us to see, we're only going to color in the first 2. Who ate more cake? I need you to get your life together. Who ate more cake? Colin Murphy, who more cake? How do you know?
Because his two colored in spaces are bigger than Blake's.
The amount of space of cake that Jackson ate goes from here to here. That's bigger than this amount of cake that was eaten.
That's a whole block there.
Hey, wait. Jackson has smaller numbers. How is it that he ate more cake? 6 is bigger than 4. What the what? Maddie? Why is that? I thought because 4 is smaller than 6, that would be smaller.
Well, it's because when you have a bigger number, you have to split it up into smaller pieces for it to be eaten.
Awesome. A little louder for the friends in the back, Maddie. Can we do it again?
Well, it's because whenever you have a big number, you have to split up into smaller pieces so it's easy.
If you are sharing things with more people, you are going to get a smaller amount. If you are sharing things with less people, you are going to get a bigger amount. So even though 4 is a smaller digit than 6, we still know Jackson ate more. So underneath that, you need to write Jackson ate more cake. And then I want you to tell me a sentence of how you know. We just talked about it. Just to review our symbols. Which way is my big mouth going to go? Remember my big mouth for my less than or greater than symbol. The open part goes toward the bigger number. So my bigger number is what number? Piper? 2/4. So this becomes this. And the way I read this is I would say 2/6 is less than 2/4. Does that make sense? Question? Go for it.
I have a question about the greater than less.
Go for it.
When you always have the greater than sign,
Yep.
does it have to go a simple way, or does it like just go to the greater than?
So the way I like to remember it is to not worry about one being greater than and one being less than. I just want to remember to point it at the one that's bigger. And then when I read it, I just need to read it so it makes sense. So in this case, it would be 2/6. I know is the smaller one because I'm not getting the big mouth. 2/6 is less than 2/4. If this was switched, it would say 2/4 is greater than 2/6. You can memorize which way means what, but I wouldn't worry about that part. Just remember the open part, the mouth part, that's pointing at the biggest number. Okay? All right, let's try our next one. You're going to do some of this on your own. It reads, the gray squirrel ate 3/4 of the acorns. The brown squirrel ate 1/4 of the acorns. Who ate more of the acorns? How do you know?
Oh.
You are comparing 3/4 to 1/4. And you are going to draw a bar model. Go for it. What you need, Ava? Yep. Alright, so you should have 2 equal size bars drawn.
Okay, now.
One should be labeled B, and one should be labeled G. Why is one labeled B and one labeled G? What does that mean, Caleb? The brown squirrel and the gray squirrel. Alright, the brown squirrel only ate 1/4. So how many pieces am I breaking that bar into? Aiden, sit up. Caleb? 4, because my denominator tells me what I'm breaking it into. How many pieces do I shade in for my brown squirrel? Ava? Brown squirrel. 1. Alright, my gray squirrel ate 3/4. So how many pieces am I breaking that bar into? Madeline?
4 pieces.
I'm breaking it into 4 pieces. Because the denominator is the exact same. How many pieces am I going to shade in for my gray squirrel? Aiden? 3. My numerator tells me who ate more. How do you know? Who ate more? How do you know? Elliot, who ate more? How do you know? What do you know from our model? How do you know from our model who ate more? Look at it. I don't know is not a good answer. Look at it. How do you know who ate more based on our model? Yes, the gray squirrel because it's bigger. That's a bigger amount of space that he ate. So you need 2 sentences. The gray squirrel ate more because blank. That's fine. That's fine. What?
The gray squirrel ate 3/4, and there's only 1 left, so the brown squirrel ate 1.
Yep. This is not, turn around Aiden, the only strategy. This is not the only strategy. Bar models are my favorite because they're big and you can see them pretty easy, but it is not the only strategy. Just like we can represent a fraction with a bar model or a circle, circles would be awful, or a number line, we can compare fractions also on a number line. If I'm comparing fractions, how many number lines do you think I'm going to need? How many fractions do I have? 2 fractions. So how many number lines do you think I'm going to need? Do you think I'm going to have 1 short number line and 1 long number line?
No.
They have to be the same. All right, so let's move on. We're going to try, we're going to try some number line comparisons. So if you want to turn the page, if you need page space, if not, you can just go underneath what you've already done, that's fine. So this time we're going to compare using a number line. I think you're going to find it feels very similar. Very similar. Johnsonville School and Jacksonville School use the same amount of paper. That's important because we know our holes have to be the same. Have to be the same. Johnsonville School recycles 3/4 of their paper. Jacksonville School recycles 3/6 of their paper. Who recycles more paper and how do you know? So, first things first, just like with our bars, we're going to draw 2 number lines. I would go pink line to pink line. We know, because we've talked about this, our number line comparisons, anytime we compare fractions, that whole has to be the same. What are my endpoints for my number lines?
both of them?
Yep.
Endpoints?
Mhm.
1.34. It's gonna be four parts and 3 segments.
Okay, you're not listening to my question. What numbers go on my endpoints?
Oh, 1.
Which one gets 1?
1/4. The first one.
The first one is 1?
1/4.
No, it's not 1/4.
Endpoints. So
Endpoints.
0.
0.
And then 1.
1. 1 whole, right?
Oh.
0. 1 whole. Let's make the first one, how about Johnsonville? And we're going to put J-O.
That's what I mean, J-A.
And then J-A to represent Jacksonville, since they both start with the same first letter. Okay. So we know Johnsonville recycles 3/4 of their paper. How am I going to show that on a number line? I need to break that number line into parts. How many pieces? Aviana?
3/4.
I know. How many pieces do I break it into?
4.
4. Because that denominator tells me how many pieces make a whole. 4 is an even number. I can start in half. Label your number line.
Okay.
0 represented as a fraction is what, Sabrina? 0/4. 1/4. 2/4. 3/4. 1 whole represented as a fraction. Kaylee? 4/4. Very good. It drives me nuts when y'all don't label your number line. Every single tick mark. It's just laziness if you choose not to. Alright, now we have to show 3/4. How do I do that? Jackson, how would I do that?
You can color into 3/4 or you can jump.
Yeah, I think a lot of you like to jump, but you could do any kind of model. As long as you get all the way to that 3/4 position. Whatever picture you choose to do, as long as it starts at 0 and goes to 3/4, we are good. Wow, that's pretty big. 3/4 is pretty close to 4/4. It's a lot of paper. Alright, Jacksonville only recycles 3/6 of their paper. So how do I break apart that number line? Sabrina? To 6 because of that denominator.
Here's a bag for tonight.
Appreciate you.
I don't know what y'all
Can you put it in that purple bin? Because that's where all my trash bags go. Thank you. 6 is an even number, so I can split it in half. And then I can put my 3 on this side, my 3 on that side. I need to label my tick marks. Tom Murphy, what is 0 represented as a fraction?
0.
Good. 1, 6, 2, 6, oops. 3, 6, 4, 6, 5, 6. 1 whole represented as a fraction, Kaylee? 6, 6. Jacksonville only recycled 3/6. So we're going to start at 0 and do some kind of jump, circle, however you want to do it. So if I write my comparison like this, 3/4, 3/6, which way is my big mouth going to be facing? Aiden?
6/6.
That's not an option. I have 3/4 and I have 3/6.
Oh. 3/4. 3/6.
Is 3/6 larger? Which one is larger? 3/4 because it goes a farther distance. So my big mouth is going to look like this. Can someone read this number sentence to me? Emily, you want to try and read it?
3/4 is greater than 3/6.
Very good. 3/4 is greater than 3/6. Who recycles more paper? Colin Murphy? Johnsonville recycles more paper. How do you know, Colin?
Because the big mouth is pointing at 3/4 and
How do you know based on your model?
Johnsonville had bigger jumps, which made all their 3 pieces bigger than Jacksonville.
I like it. Their pieces were bigger, so their total was bigger than Jacksonville's. You need to answer this sentence on your paper. Who recycles more paper and how do you know?